Welcome back to the channel. Hope everybody's doing well. And in today's video we are revisiting the XP1000 VDE torque screwdriver from Draper Tools. I tested this one previously alongside a few other VDE torque screwdrivers, and based upon brand new out of the box tests, this was by far the worst performer. I will leave a link to that video in the description box below, but I'll just put up this graphic from that video to show the test results for this screwdriver. And you can see over the out of the box test it was around about 7 to 9% out of tolerance. I then tested it at 500 operations and then after 1000 operations, and it didn't improve. In 500 operations actually slightly worse. At 1000 it returned back to similar out of the box test results. And that's a bit of a disappointment, because it's Draper Tools. They are reasonably good quality. Feeding a VDE torque screwdriver, I would say this would be aimed more at professional use rather than DIY use. So it's not good that it was reading out of specification. What I decided to do was go out and purchase another version of this. This is actually the 9-piece set, and I purchased this from Amazon. So I went out and purchased the 19-piece set, which is this one here. You can see in this one you've got a couple of extra handles and a few more extra blades in this in comparison. And I purchased this from a completely different store, a local tool store I got this one from, and then ran that through its tests. Unfortunately, that was just as bad, if not worse, than this screwdriver. So what I then did was went out and purchased the mechanical version of this screwdriver. And that comes in this little blow molded case that you see here. A few bits here. This is a 13-piece set as opposed to the 9-piece and 19-piece set, and obviously it's quite a different screwdriver in comparison to what you have here, but it looks to be physically the same, different plastics. Obviously the mechanism here is slightly differently because it's not VDE rated. Now this one did perform a little bit better. Put up the test results. That's the test results of these 3 screwdrivers just straight out of the box, and you can see we've got our original one, which was 7 to 9%. This new 19-piece one is 10 to 12% out of tolerance, and it was 100%. All of the tests that I did on this all gave a reading above the specified 6% tolerance of these screwdrivers. Our mechanical one there, you can see around about 50% of the results are out of tolerance, and we're running from 4.3 all the way up to 8.1%. So some of those readings are in tolerance for that mechanical one. So not sure how well you can see the certificates here. This is my original 9-piece screwdriver. The test designation on this is number 12,000. Test date is 1st of August 2023. Serial number is E54113. This screwdriver that I purchased from a more local tool shop, again it's tested by 12,000, but the test date is 21st of December 2022. Serial number is E45359. So what are we looking about? 10ish months in between these two screwdrivers. This one obviously being the older of the two. I guess smaller tool shops don't sell as many of these as the likes of Amazon would, although I did get this at a slightly cheaper price than I could have got it at Amazon. Our mechanical one, that is again tested by 12,000, and the test date on this is 13th of September 2023. So this is the newest of all the screwdrivers. Serial number is A13669. But obviously, with it being the mechanical design, you wouldn't expect this to be manufactured at the same time as either of these. And as far as I'm concerned, the difference between these two means these are highly unlikely to be from the same batch. And therefore, having both of these come out as being out of tolerance, that kind of gives me more concern as to the quality control that Draper are putting on these screwdrivers. So I'll just put this little table up here. This is my original test program for these screwdrivers, this 9-piece one and all the other screwdrivers that I tested. Now you can see that the tests were varied over a number of sessions and a number of days, using different torque values and different number of operations. I did that purely and simply because I felt that's the best way the screwdriver would be used. Highly unlikely you're just going to go out there, set it to 3 Newton meters and use that for 1,000 operations. It just wouldn't have happened using it on a board or a panel full of contactors or whatever. You would have to change the torque setting depending on what the device were that you were actually tightening up. Now the actual values for the torque setting that I used, they were derived from manufacturer settings for torque values in consumer units. This little graphic here, this shows you the range of torque values that you can get from different manufacturers for consumer units, from the main incomer, the MCBs, surge protection devices. Where I could find that data, I just amalgamated it all together and then looked at averaging values across that, picked those, put those into my test program, and that's what I tested the 1,000 operations over. However, if we go to ISO 6789 Part 1, which is the standard for these screwdrivers, clause 5.1.7 is the endurance test for these, and that actually specifies 5,000 cycles at the maximum torque setting of the tool. So for these two new screwdrivers, the 19-piece one and the 13-piece mechanical one, what I did was operate these at maximum torque and then tested after 500 operations and then again after 1,000 operations. And what you see here in these two tables is the results of that. So for my 19-piece VDE set, after 500 operations we were around about 8 to 11%, so still out of spec and no real great improvement from the original set of results, out of box set of results really. However, after 1,000 operations you can see a significant drop. It's now down to 4.9% to 6.4%. So whilst a few of the readings were a little bit out of tolerance, generally the screwdriver was seen to be operating in tolerance, which is a much better result. If we look at our mechanical one, our 13-piece set, you can see at 5.9% to 6.4% after 500 operations, so it started to come into spec after 500 operations. After the 1,000 operations we are now down to 3.9% to 4.8%, so we are now 100% within specification. And I think if I operated the VDE screwdriver, the 19-piece one, a little bit more, that would soon come back to within specification as well. So based upon that, having done all of those tests on those screwdrivers, I went back to my original XP1000 unit from the 9-piece set and I ran this for 5,000 operations overall, which is the endurance test in the ISO standard. Again, put the test results up for that, and you can see that after 1,500 operations, so that's another 500 operations upon the 1,000 operations already carried out on this, but they were at maximum torque. You can see we've dropped down to 4.8% to 6.7%, so we're starting to get a unit much more in tolerance now. After another 500 operations, total of 2,000 operations, we are now fully within specification and we are 2.6% to 3%, so a very low spread and totally within tolerance. And then after the full 5,000 operations we have now dropped down to minus 2.5% to 1.6%, so it's totally within specification and operating okay over those 5,000 operations. It just seems to take a little bit of time to wear it in and get it operating within spec. So that's test results from all the tests carried out on the Draper screwdriver here. I will leave you with this little plot. This shows the tests carried out on the screwdriver from the 9-piece set, the original one, over the full 5,000 operations, and you can see how it performs over time and slowly comes to within specification and remains within specification over those 5,000 operations. So it does seem to get there eventually, just takes a little while for it to wear in, but it seems to be operated at the maximum torque for a little while to get it to bed in and start performing within tolerance. Obviously that's based just on the two screwdrivers that I've tested. You can see the mechanical one did test a little bit differently, although its theme was kind of there of being out of tolerance and then needing a bit of work to bed it in. other screwdrivers may be perfectly okay. I just don't know. I can only go by the screwdrivers that I've tested within this video. But that'll be it for this one. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.